Let's analyze a second function from a calculus perspective. So as I look at the function x cubed minus 4x all over x squared, I start by trying to factor it and just kind of analyze what I can algebraically. So start by factoring out the GCF, and then I recognize, oh, so this would be x plus 2 and x minus 2. And the denominator, of course, is x times x. Just kind of helps me see any unique factors, because this would cancel, and I still would have a remaining x factor in the denominator, indicating that there is a vertical asymptote at x equals 0, since that's going to be the restriction in the denominator that x cannot be 0. So my domain will definitely break there at 0. And I'm going to consider any x-intercepts, which will come from the numerator. And since two of these x's would cancel, one from the top and the bottom, my x-intercepts where I let y be 0. So I'd have x plus 2 and x minus 2 remaining for my x-intercepts. So my x-intercepts would be plus or minus 2. So I'm going to put those on my sketch. Now I'm going to go to my graphing calculator, and I see a function that looks like this and like this. Okay, now I can talk my domain. I've already established that the domain gets broken at 0 from the restriction on the denominator. So my domain is negative infinity to 0, union 0 to positive infinity. The range, well, this graph goes infinitely downward and infinitely upward, so there's no break in my range. This is all real numbers, or I can say negative infinity to positive infinity. I would also accept this notation, all real numbers. Okay, how about any symmetry? Just looking at it, I definitely don't have even symmetry about the y-axis, but there may be rotational symmetry or odd symmetry about the origin. So I'm going to zoom in here to show this algebraic test. This is where I substitute in negative x into my function. So everywhere there was an x, I'm going to plug in negative x, and then I'm going to simplify this. So this would produce negative x cubed plus 4x over x squared. So how does this compare to the original? Is it exactly opposite? Well, if I factor out a negative, I would have positive x cubed minus 4x over x squared. So it is exactly opposite of how it started. So f of negative x is equal to the opposite of f of x, which is the algebraic test to conclude that you have an odd function. So therefore it is odd. And let's zoom back out so we can see our whole scenario again. All right, so let's talk continuity. We have a vertical asymptote, so we definitely have infinite discontinuity at x equals 0. Now let's talk, where's this function increasing or decreasing? So if as I move from left to right, it's increasing from negative infinity all the way to 0. It breaks at 0, and then it continues to increase again from 0 to infinity. So it's really increasing on the entire domain values. So I just rewrote the domain again and stated that it was increasing. Now, as far as any extrema, either local mins or maxes, I don't see any, and since it goes infinitely upward and downward, there is no local or absolute extrema, so I'm just going to say none. So my x-intercepts, we actually looked at those already. They are positive and negative 2. The y-intercept, well, it never crosses the y-axis because we have a vertical asymptote at x equals 0 at that vertical line. Vertical asymptotes, we said we had some. They were x equals 0. Horizontal asymptotes, there are none here. And finally, let's look at the end behavior. So as this function goes to the left, as x approaches negative infinity, it is dropping or approaching negative infinity on the left. And on the right, it is approaching positive infinity as x increases.